Welcome. 2021 is going to be a magnificent year because it's got to be better than 2020, doesn't it? Doesn't it? Just absurd events in 2020. But we don't have time for all of that, obviously. We are going to focus on GAMSAT organic chemistry. And so today, first of all, I have to adjust your expectations because it's not common that when you are trying to learn something, that you are with people with such a variety of experiences. So among you are those who are not really quite sure what organic chemistry means, what the definition is, and what it covers. And there's those among you who, this is revision. You've studied this already. In fact, you've sat the exam before, and you did, some of you didn't do so well, some of you did fairly well. And so it's quite a range. So I just want to adjust your expectations because we're going to try to respond to the full range. So I want to teach some very basic issues, about GAMSAT organic chemistry, so that it is a benefit to someone who's just, walked in here from the pub or something, if that's permitted in your location. And then also, we're going to build, and then we're going to go up to, GAMSAT level practice questions. So the kinds of things that you could expect on the real exam. So obviously, if you have not prepared, if you haven't watched any of the, the videos or read the books or whatever, and you're just, coming in here, don't worry, you're going to learn something. But at the end, it's going to be a bit mesmerizing. But then, for those of you who have experience with GAMSAT organic chemistry, just be a little patient. We're going to try to get everyone on board, and then we'll get to your level at some point. So you all have a handout. A link should have been given to you. If not, it's coming. And then you will have this handout, and it will have the practice questions. Because I'm going to talk for probably 5-10 minutes. And after that, I'm going to stop talking to allow you to try the questions according to the new GAMSAT schedule, which we will get to later. And then after you've tried the questions, then we will discuss the work solutions. And then at the end, which is really great, last year we were celebrating our 10th year anniversary, providing GAMSAT courses, and then we started giving away free books and ebooks. So we just have our brand new Master Series books came out, were printed for the first time in January. So these are the most up-to-date, practice materials for this exam. And we're giving one away free every single week, right up to the exam. And so we're going to give you a link for that at the end of the webinar. So, one of the things I like to tell students, just to make sure that you have this in the back of your mind, is that when you're preparing for organic chemistry for GAMSAT, you might have in your mind that you have to spend 60 hours or 100 hours or some nonsense like that. But actually, it's somewhere around 6 to 8, 9 hours of videos that will give you the basic information that you require for GAMSAT level. And then after that, you have to do lots of practice questions. And you can get those videos either on our website, gamsatprep.com, or you can go to Khan Academy and go through their introductory level organic chemistry. Don't get involved in the mechanisms. That has nothing to do with this exam. I put a link there for problem-based learning for you. And we record our webinars, and they're available for free afterwards. So if you miss something, if something goes by very quickly, no problem. And I really appreciate those of you who are, help some students who might get a little lost during the webinar. And if you feel fine, if you feel secure with your knowledge, then, to be able to just, type something in the chat window to help somebody out is helpful. So January and February, we used to give live seminars on campus, Perth, Adelaide, Brisbane, Melbourne, Sydney, London, in Dublin as well. But of course, that's done. Anybody who wants to try that now will get arrested. So now it's all virtual. It's all online, except for our virtual reality practice exams, where students wear masks on computer, like the new exam, new format, all of that. Those are on campus because those are done locally. I wanted to also mention to you that there's a free medical school interview program. I don't mean fake free where you have to pay for something extra somewhere else. No, if you come to our website, you click on medical school interviews, we have hours of medical school interview videos and content, and it's always free. So we're not adjusting that. We don't have any other program to whatever. Okay. Okay, I just want to. Oh, yeah. This says we have 5,000 questions. It's actually 6,000 now with the new books. It says 4 textbooks. It's actually 7 now. It's absolutely absurd. We've added hundreds and hundreds of pages of new content to be in line with the 2020 exam. Yes, questions reflecting that. And as many of you know, the half of the questions are repeated from year to year. We never repeat the actual question, but we always repeat the reasoning that was used. Now, I just want to give you a little bit of background on something very specific about GAMSAT organic chemistry. It's going to change the way you study for this subject. We really carefully analyze all ACER's practice materials, all the posts students have in debriefs and all of that. I want to be specific, over 440 multiple choice questions. As you know, I put them on free on YouTube with work solutions step by step. But I went back and I reanalyzed all those questions and including the debriefs that students have from the 2020 exam, 2019 exam. And I can say now with clarity and data, the data I put in the books, over 50% of the questions have a basis in maths. Yeah. Okay, now I know you know that 40% of GAMSAT is biology, 20% general chemistry, 20% organic chemistry, 20% physics. But if you look at analyze every question one at a time to see, but what did you need to know to answer the question? Over 50% it's maths without the necessity of knowing the biology, general chemistry, or physics. That's mind-blowing. In addition to that, though, organic chemistry is not in this category. So what you're going to be looking at tonight is something that's unique to this exam. GAMSAT organic chemistry is not based on graphs, tables, and diagrams like the rest of Section 3. Mostly the rest of Section 3. GAMSAT organic chemistry is based on 3 things, and we're going to be analyzing a couple of those things within the next hour. One thing it's based on is nomenclature. You have to know how to name organic chemicals. And so this is practice. Okay, so you either go through the book or you go through Academy or you go through something, but you have to learn how to name basic structures. And we're going to be talking about that in just a bit. The next thing is I'm going to say both of the expressions, pattern recognition and geometric reasoning. Pattern recognition, geometric reasoning. These things will not help you for any other subject in GAMSAT for the most part. And to be honest, it doesn't even really help you for real organic chemistry. It helps for GAMSAT. So first of all, pattern recognition. What does that mean? If you're the type of person who can watch one of those Sunday comics where they show you a picture of something and then they show you a picture where some things have changed and you have to find the 3 or 4 things that have changed and you can identify those things that are different from one comic to another, that helps you with GAMSAT organic chemistry. That does not help you for real organic chemistry, but it definitely helps for GAMSAT organic chemistry. They want to see that you can recognize the patterns. In normal organic chemistry, you have to focus on the mechanisms. How did that happen? Where's the nucleophile? Where's the electrophile? That's normal organic chemistry. But ACER's not interested in that unless they give you that information in the passage. And so that's pattern recognition. And the last thing, the third thing that completes your preparation for proper GAMSAT organic chemistry is called geometric reasoning. Geometric reasoning is when you can look at something and you can imagine what it looks like upside down or left, right, or as we say, laterally inverted. So if you can imagine moving things around in space, and if that's natural to you, you big bonus, okay, for this exam. And if it's not natural, it can be learned. Obviously, it just takes a few weeks of problem-based learning, and you can get there. You're going to look at some things that'll make you a little dizzy today. It might make you dizzy. When you look at it for the first time, it won't make you dizzy. But when you look at it after we talk about it, then it's like a Rorschach test. You've got to consider a completely different perspective of what it might look like. So anyway, you'll get that feeling today, and you'll have a sense of what we mean by pattern recognition and geometric reasoning, and also with regards to nomenclature. Okay. So I'm not alone today. You guys probably know this already. There's G here. There's Benj and Vivian. So I do have assistants. So if there's a technical problem or such thing, just please post. Otherwise, I expect that everybody has access to the handout. You can look at me looking at my handout, or you can look at the one that is before you. Basically, every minute or two, I will check to see if somebody has some concern that has not been answered, but otherwise, I'm going to continue. Okay, so first, the basics of the basics, okay? In order to be able to name organic chemicals, you have to know what the basic prefixes are. These prefixes just have to be memorized. There's no way around it. And so you can see in your handout that if there is one carbon, the prefix is going to be meth, and 2 is eth, 3 prop, 4 bute. Bute comes up on the exam all the time, bute and pent and prop, because they're in the middle, sort of. Pent, of course, like the Pentagon. I can't believe Donald Trump was there. 5, and then a hex, 6, hept, 7, oct, like octopus, 8, non, like 9, and dec, like a decagon, is 10. And then you see the next column, it says alkyl groups, like a YL. And I understand that many people pronounce this differently, but alkyl groups with a YL. And this is an alkane missing one hydrogen. We're going to talk about that and see that again, but it's an alkane missing one hydrogen. Now, look at the basis of how you name organic chemicals. It's not based on hydrogens. It's not based on fluorines or oxygens, which we breathe every day, and nitrogen. It's not based on those things. It's based on carbon. We are carbon-based compounds, and organic chemistry is the chemistry of carbon. And carbon is so magnificent and amazing and whatever because of its structure. It can do something which is really quite incredible. You see, you're going to see in chemistry many molecules that can bond to one other thing, many molecules that can bond to 2 other things, 3 other things. Carbon can do something very unique. It can bond to 4 other things, but then there's a diversity in the ways that it can bond, such that it can bond to 3 things, or 2 things, or 4 things. But even when it bonds to whatever combination of this, it can create enormous chains of molecules, just enormous chains, thousands and thousands of carbons in a row. And because of this incredible ability the carbon has, it is the chemistry of life itself, organic chemistry. And please remember, carbon is it's a tough atom. A diamond is made out of pure carbon, and they use diamond to drill through metal and concrete. And your body is made out of that carbon. Now, of course, it's structured a little differently, obviously, but it's made out of that carbon. So the backbone of these molecules is incredibly strong. Now, let's talk about alkanes. Now, you might look at, if someone can please put a link to the handout just from time to time, you might look at, you might hear the word alkane, and it might feel foreign to you. None of these molecules are foreign to you. These molecules are the molecules in your body. They're in your room. They're in your kitchen. So, for example, alkanes, These are molecules that end in ane. So you already know what a propane is. You know, you've heard of propane. Now you have proof. Prop is 3 carbons and ane is an alkane. So it's, and we're going to talk about that. And you've heard of butane, lighter fluid. Octane, high octane gases for cars. So you are familiar with this. And you can see that these are carbon-based compounds. And if you burn it, if you break this down, you produce carbon dioxide and water. And this is how famous carbon is. Carbon is one of the few atoms that has a tax associated with it. The carbon tax, and that's how famous this atom is. Now let's look at that. Look at this hydrocarbon. You've heard that expression too. You've heard hydrocarbon. Well, this is what it's referring to. It's referring to these molecules that you see at the top row, in which they all have just hydrogens and carbons. So they're called hydrocarbons. And you know that some of these are ancient molecules that have been on the planet for millions of years. Now, look at the molecule at the top left, that hydrocarbon. Look at how each carbon is indeed bonded 4 times. It's connected 4 times. Now, some of those connections you see, it's just a straight line, but some of those connections are triangles, sort of like triangles. The dark triangle means it's coming towards you. The broken triangle means it's going away from you, and it's trying to get you to think about something. These molecules are not flat on your paper or on your computer screen. These molecules are 3-dimensional things. And in fact, it's a very special shape that you'll hear of as you do your preparation, called the tetrahedron. And the molecule itself, we say it's a tetrahedral molecule, where carbon is in the center of a shape that is like a pyramid. So it's like a pyramid. Now, it's hard to really imagine it right now, but it's a pyramid. And carbon's in the middle of that pyramid with an atom above it and then 3 atoms below. So this, we say, is a saturated hydrocarbon. Saturated because I said before, carbon can bond 4 times. Yeah, that's the maximum. Carbon can never bond 5, 6, 7. No, maximum is 4 times. When carbon is bonded to 4 atoms, it's saturated. It's fully saturated. Anything less than 4 atoms, it's unsaturated. And you've heard that before. You've heard about saturated fats and saturated margarine, butter, or unsaturated margarine. This is what it's talking about. It's talking about whether or not carbon is fully singly bonded, and each carbon is bonded to 4 different, each carbon is bonded to 4 atoms, or is there a double bond or a triple bond? Because if it's a double bond or a triple bond, no, that's not saturated. That's unsaturated. So this is the nature of what we're looking at right now. Alkane is a saturated hydrocarbon. Now, what's the name of the one that we're looking at? Just type the name of the one that we are looking at. The saturated hydrocarbon in your handout. What is its name? Everyone should be able to say its name. You know what the prefix has to be, and you know how it has to end. Lovely, lovely. So you count the carbons. 1, 2, 3, 4, 5 carbons. It has to be pent according to the schedule. And then it's fully saturated. So it's an alkane, it's a pentane. Beautiful. Now let's try to exercise your geometric reasoning and your pattern recognition as you look at the skeletal molecules. Because the molecule that you see in full, the alkane, almost impossible you will draw that during GAMSAT. And by the way, yes, you will draw during GAMSAT. Yeah, I said it. I said it. You will draw during GAMSAT. Because when you have section 3, with the digital exam, with the computerized exam, you'll be given 2 A4 sheets of paper. So you should have A4 sheets of paper right now on your desk, because you're going to be drawing, when you start doing some practice. So when you look at the short form, the skeletal form, these are the things you need to know. Every corner of a geometric figure represents a carbon. So there's a carbon at every corner. And The end of a line is a carbon if there's nothing else there. Do you see what I'm saying? Because if there's nothing at the end of this line, that means that is a carbon. But do you see some of the other molecules? There's like an OH, an O at the end of the line. There's no carbon there. There's an O. That's why the O is there. Okay. But if there's nothing at the end of the line, that's a carbon. So look again. This is pentane. 1, 2, 3, 4, 5 carbons. Done. Okay. Alkene. Alkene has a double bond. As soon as you have a double bond, it ends in -ene. Alkene. You identify where the double bond is when you name the compound. What is the name of this alkene, please? Just type it in the chat window, please. What is the name? Please identify. Heck, you're starting off well, but please identify where the double bond is. When you give the name, it has to end in -ene because there's a double bond, and then you have to give a number as to what is the lowest number that the double bond is attached to. Okay. Yes. So we have we have a lot of 2-hexenes coming up, and we have some fancy hex-2-enes as well. So just to clarify, by the way, I just need to know from you guys, when I move my cursor, do you see my cursor moving around, or you're just seeing the file? Because it'll change the way I teach. You do see my cursor. Wow, wonderful, beautiful. Okay, so because we usually use a whiteboard, but COVID has just kicked everybody in the butt this year, and so we're starting with this. Okay, so we look at all these carbons, 1, 2, 3, 4, 5, 6 carbons. Okay, and then we look at the lowest number, 2. So 6 carbons means hex, double bond, ene. 2 is the lowest number that has the double bond. So 2-hexene is sort of like the normal colloquial way to say it, but the IUPAC, which means the official way to say it, is hex-2-ene. But Acer does not play that game. If they're going to make a difference between 2-hexene and hex-2-ene, it's because they gave you the rules in the passage. If they don't give you the rules, they're going to use one or the other, and frankly, usually they use 2-hexene, which is the colloquial way to do it. Okay. So now we have a conjugated alkene. Conjugated alkenes, let's say every second or third GAMSAT has conjugated alkenes on it. And you'll find it in the pink booklet, an entire unit on conjugated alkenes. And basically it comes down, can you see the conjugation? And what the conjugation is in introductory level organic chemistry, the conjugation is double bond, single bond, double bond, and always having that rhythm, double, single, double, single, double, single, double. If you have that continuously, you have a fully conjugated molecule. So double, single, double is the conjugation that we're talking about. And it's a very special thing because it helps molecules to be more stable. And down below, bottom right corner, one of the most famous conjugated alkenes in the known universe is the benzene ring. And you can see it's double, single, double, single, double, single, and goes in a circle. And please imprint that on your mind because we're going to have a pretty fancy question at the end of this webinar with that. Okay, so we've got a conjugated alkene. Deliver it to me, please. What's the name of this conjugated alkene? Please beware, there's 2 double bonds. You have to be able to identify where they are and be able to say something that identifies the 2 double bonds. So what's the name of it? Lots of good names. Those are very good names. They're not perfect yet, but you did great. You identified where the double bonds are. And yes, Annalise just added this special extra thing. There's 2 double bonds, and so we have to add di-ene. It's not an ene, which would mean 1 double bond. Now, it's great you put the 1, 3. That's great, but now you have to put the di-ene. So if there were 3 double bonds, triene. Okay, so and you can see the names up here: di, tri, tetraene, pentaene. If there are more double bonds, you have to use that for that part. So 1, 3, great. So first of all, lots of great saying bute, because 1, 2, 3, 4 carbons, bute, diene, 2 double bonds. Lowest number 1, 2, 3, 1, 3, butadiene. Great. And if you have the Gold Standard book, you saw the depth of my how do you say, how do you say terrible humor is I put a head here. I put a head here, and it said, "Help me, I'm dying. Help me, I'm dying." Okay. Anyway, so alkyne, Y-N-E, triple bond. Now, before you try to give a name to this alkyne, please be careful. Try to think, why does the triple bond end there? How many carbons must there be for the triple bond to end and start in that way? Okay, what's your name for this alkyne? So now it's still a hydrocarbon, but it has a triple bond. Unsaturated hydrocarbon. What's its name? One at a time. Yes, yes, the flood has started. Wonderful. Lots of pent. Great. So you guys have seen that the only thing that makes sense is if there's a carbon here, a carbon here, a carbon here, a carbon here, a carbon here. So that's 5 carbons. Pent, it has to end in ine, and it's at the second one. So 2-pentyne would be the colloquial way. Pent to ine, YNE would be okay. So here's another couple of molecules that have come up on the exam almost every time. These 3 molecules: ketones, aldehydes, carboxylic acids. So what just happened here? We had hydrocarbons, only hydrogen and carbon. We are now into oxygen-bearing molecules. So obviously tremendously important for us because we breathe oxygen, and then next, nitrogen-bearing molecules. So when you think about your human body, you might think, oh, there must be tons of different atoms in your body. Could you believe 6 atoms represent there's over 100 atoms in the periodic table. 6 atoms represent 99% of your body, 99%. Carbon, hydrogen, oxygen, nitrogen, all of the ones that you're seeing right now, phosphorus, and calcium. Organic chemistry doesn't care about calcium. That's a general chemistry issue. Okay, so now oxygen, ketone, carbon, double bond. Ketones end in -one. Aldehydes end in -al. Carboxylic acids end in -oic acid. You see the similarity. All carbonyl groups, that's a carbon double bonded to oxygen groups. You see the similarities? Okay, so OH, it's an acid. Of course, definition, proton donor. Then we have an ester. Okay, now we have to talk about what are these R's, because Acer loves R's. Acer has passages where they talk about R prime, R double prime, R triple prime, and they want to see if you can follow them, which is all just geometric reasoning. So in traditional organic chemistry, R represents hydrocarbon. These things up here. Yeah, R can be an alkane, it could be an alkene. We wouldn't literally say alkane or alkene, we would say alkyl, because an alkane minus a hydrogen can attach alkane, and that's an alkyl group. And actually, an alkene minus a hydrogen is an alkenyl group. So if you remove a hydrogen, then you can attach it to something. And when you attach it to this central carbon in this way, with this structure, this is how we have carboxylic acid and ester. So ester means that there's going to be a hydrocarbon here in replacing the hydrogen, and an acid halide. Now, most of you know that halide represents the atoms in the 7th group of the periodic table, and you've heard of all these things before. It ends in "ide," like fluoride, which you have in your toothpaste and in your water. Of course, bromide, iodide, chloride, which you have in the swimming pool. So those are the acid halides. And then we start going into other types of very special, bases for molecules that form proteins and other things in our body. So one thing we start with is the amide. So we replace the OH and carboxylia with NH2. Hopefully you know that there's a very special molecule called ammonia. It's a household cleaning fluid. It's a weak base, and ammonia is NH3. And so you see the AM here, the AM and the AM, that's referencing ammonia. So instead of NH3, oh, it's attached, you remove a hydrogen. Just like you removed an alkane, you removed the hydrogen to make alkyl, and then you attached it. Okay, so NH3, ammonia, you remove a hydrogen, now you can attach it, amide. And then, okay, so anhydride is the only one you don't have to memorize that we've seen, okay? That's the one. ACER's never going to ask you to have memorized that. If it comes up on the exam, they're gonna explain what it is. The other ones you're expected to know. Now the amines. So again, like ammonia, but instead of being NH3, there's a hydrocarbon attached. Primary amine, secondary amine, tertiary amine, quaternary amine. Actually, we call it a quaternary ammonium salt because NH3 is ammonia, NH4 plus is ammonium. So anytime nitrogen is bonded 4 times, it is ammonium. So this is a quaternary. Quaternary refers to 4 bonds, ammonium salt. Okay. Primary, 1 bond. Secondary, 2 bonds to hydrocarbons. Tertiary, 3 bonds to hydrocarbons. This concept of primary, secondary, tertiary comes up repeatedly on the exam. And normally, not always, but normally they'll still repeat it. They'll explain it to you again. When the central atom is bonded to hydrocarbons, okay. But of course, if you know this in advance, you're a little faster, that's all. So now we have the same concept, primary, secondary, tertiary, but now with alkyl, which is hydrocarbon, saturated hydrocarbon, halide, which is 7th group of the periodic table. So these are bromide, fluoride, iodide, chloride. So this is primary, so only 1 hydrocarbon bonded to the central carbon. Secondary, 2 hydrocarbons bonded to the central carbon. Tertiary, 1, 2, 3 hydrocarbons bonded to the central carbon, and it's a halide. And then alcohols. So alcohols, of course, you have a little bit of familiarity with alcohol. And that alcohol that you have familiarity with, I hope it's ethanol and not methanol, because that's dangerous, but ethanol. And but ethanol is just one of, obviously, a family of molecules that have the OH group attached to the hydrocarbon. And so this is alcohol. And by the way, I could have also put here primary, secondary, tertiary alcohol. Could have done it. Would have been, because it applies to that as well. And then ether. So an ether is, we have oxygen in the center, and instead of a hydrogen on one side, we have another hydrocarbon on the other side. And then we have the thiols and thioethers. If this comes up on the exam, this will also be information provided to you in the passage. They won't give you necessarily background information on alcohols or alkanes or alkenes, but thiols and thioethers, yes. And you can see that the only difference is that oxygen is replaced by sulfur. And if you know the periodic table, sulfur is just below oxygen in the periodic table, and so it would be a natural thing. And then we have amino acid. Amino acid is not a functional group. Amino acids contain 2 very important functional groups, an amine and a carboxylic acid. And tell me about that amine. Is that a primary, secondary, tertiary amine? Is that a primary, secondary, tertiary amine? So you got that right in front of you. Okay, lovely. Lovely. Okay, so yes, that's a primary amine because we just see it's just 1 hydrocarbon bonded to the nitrogen. Primary amine, 1 hydrocarbon. So that's that geometric reasoning to be able to notice that. Okay, and now we have a carbon over here. That's carbon number 1, and this is a carboxylic acid functional group. And then carbon number 2, carbon number 3 over here, and it's attached to that one. So now let's look at the benzene ring. Okay, so this part here is not the benzene ring. Okay,